Hello and welcome to today's Lincast. My name's Gordon and I'm joined by my colleague Joe behind the camera.
Hello.
And we're going to take you on a tour of the Linn factory here on yet another rainy and miserable Glasgow day. So Linn has been around for a long time, since 1973, when our founder, Ivor Tiefenbrunn, started Linn to produce and manufacture the Sondek LP12 turntable that revolutionised the turntable market. We've been going since 1973. This particular factory that we're in today, we've been here since the mid-1980s. Our original factory was based in Castlemilk in Glasgow, about 5 miles from the location we are in today. Now, we used to run a monthly factory tour here at the factory for people to come and join us and see how we do what we do. But thanks to COVID-19, we've had to cut those days short. But what we wanted to do is still to create that factory tour vibe, so you can feel like you're in communication with us and you can see how we do what we do. So hopefully you'll find this enjoyable, and we'll go on a bit of a journey around the Linn factory, starting with our metalwork area behind me, where we make all of the casework for our Linn products. So if you'd like to follow me. So in this area here is our punch. This is where we punch the various shapes and pieces of material that will create the casework for almost all of our Linn products. Behind me you can see the racks where we keep all of the sheet aluminium that we make the casework from. We use almost exclusively aluminium in our products. We only use steel in some very high strength areas. You can see the punch is now punching different shapes from a single sheet of aluminium. We'll try and maximise as much as we can from any one single sheet. Anything that we can't use will be recycled, and we do source all of our material as locally as possible from a Glasgow-based supplier. So once the material comes off of the punch, it can have some sharp edges on the side of it. So here we will use either a manual sander to take the sharp edges off, or we will go through this machine here, the Grindmaster. This is essentially an automated sanding machine that will take those sharp edges off to protect the guys who work in this area. Here we can see some metalwork that has now been folded, and you can see it starting to take shape. In fact, this is the casework of the brand new Magic DSM that we launched just a week or so ago. So this next stage here is called PEMing and masking. A PEM is a high-strength steel insert that we push into the soft aluminium. Aluminium, because it's a soft material, doesn't have a lot of tensile strength. So we use a high-strength steel insert to make sure that nuts and bolts and screws have a lot of strength so that the product can stay together and, crucially, can come apart for upgrades and go back together again.
Can I see one?
You can indeed. So this is a PEM, a high-strength steel insert. We use the hydraulic presses behind me to push the piece into the soft aluminium, and it becomes a permanent part of the casework assembly.
Excellent, thank you.
So this next stage here behind me is the masking station. This is where we mask off areas on the casework that we don't want to contaminate with paint. It may be an earth bond or an attachment point for a screw thread, but we will mask off areas before we paint it. Once we've masked off those areas, everything passes across here. So this is our wash tank. It's okay, there are no fish in this tank. In here we have a phosphate chemical added to warm water. pH level about 4.5. It has two jobs to do. The first thing it does is it acts as a degreaser to clean any contamination, fingerprints, dirt from the metalwork before we paint it. But the second thing it does is it leaves behind a really good surface for paint to stick to. Because right over here is our paint plant. So here you can see our paint plant. We use a dry powder coat process. We don't use wet paint. So the rail above me is negatively charged. Over here in this silver cabinet are spray guns. When they spray the paint, it is positively charged. So there is a static attraction between the powder and the metalwork. That means we get a really even coverage. Powder coat is also a very durable paint finish because the paint is literally baked onto the metalwork itself. So it takes about 25 minutes for all of the metalwork to pass through the paint plant. The oven itself is around about 180 degrees centigrade. When the metalwork passes out, it is completely covered, a very durable paint finish. Now we have a number of different paint finishes, as I'm sure you're aware. We have a white paint finish, silver paint finish, and a number of different black finishes. We have a smooth black finish that we can print our artwork onto. We also have a glitter black finish that has a very light glitter through the paint. And we also have a black crackle finish that is a legacy paint finish from our older LK chassis products. So you want to come this way. This is our laser etcher. So with many of our products, we ink print the Linn logo and all of our artwork onto the product. This machine is very different. This is a laser. So if you think of this machine a bit like an inkjet printer, a head will pass across and leave a deposit of ink on a sheet of paper. In this machine, a head passes across the metalwork and the laser removes the paint layer to expose the aluminium underneath, thereby creating the Linn logo. And I can show you that in action. So here we can see the laser starting to create the Linn logo on the top corner of a select DSM metalwork. The laser will make two passes over the material. The first pass removes about 60% of the paint material. The second pass removes all of the remaining paint and also seals the aluminium underneath, so there are no problems with oxidization. I could happily sit and watch this operate all day long. So let's head back this way. So for some of our products we still use an ink print. Here is an accurate fascia that is still awaiting its ink print on the front of the panel itself. And that will be done by this machine over here. So this machine is a pad printer. Essentially the silicon pad will lift an ink print from the pad here and transfer it onto the metalwork that we want to print. The big advantage of the pad printer is it can print on curved surfaces, whereas the traditional screen printing method can only print on flat surfaces.
It's kind of like a very fancy potato halves in paint at kindergarten, yeah?
You did it at primary school.
Yeah.
Okay, so let's head out of metal. So this factory itself was designed by Lord Richard Rogers, he of the Pompidou Centre fame. One of only a handful of factories that he's designed in his time as an architect. The factory itself has a very slight nautical theme. You'll see exposed stairwells and porthole windows. This is because our founder, Ivar Tiefenbrunn, is a big fan of the maritime world. He's a keen boatsman and likes nothing more than to be out on one of Scotland's beautiful lochs in his boat. Ivar has taken a step back from the day-to-day running of the company, and we are now run by our current CEO, Ivar's son, Gilad Tiefenbrunn.
That was back when we didn't have a factory.
Yes, we had to manufacture turntables on the shore of Loch Lomond.
Yeah.
So if you'd like to follow me. Welcome to Board Assembly and Test. This is where we manufacture all the circuit boards that go into every Linn product. This area actually used to be the main office for the factory when the building was built in the mid-1980s. We extended the factory in 2003 with 2 wings, one either side, so that this team could come into this area and have their own dedicated space. So we're actually at the bottom of the line at the moment. Let's head up to the start. So in this area we have 2 production lines, line 1 and line 2. So we will take what we call a raw card, a circuit board with no components on it, and what we will end up with is a fully populated circuit board with all of the components fitted. Now there are 2 different types of technology on each one of our circuit boards. There is what's called SMT components, or surface mount components. These are components that are placed on the surface of the circuit board. And then there are what's called through-hole components that go all the way through the circuit board. These tend to be the larger, more heavy-duty connectors. We do both of these processes here in this area. These are actually ExactBox 10 boards. So let's see how we do that.
Gordon, what would we print on every single circuit board?
I'm glad you asked that, Joe. So, harking back to the nautical theme, I mentioned that Ivor is a big fan of the shipbuilding industry in Glasgow. So on every Linn circuit board, you will see a little logo that says Clyde Built. I don't know if you can see that.
I think the camera's picking it up, yeah?
Clyde Built. So that harkens back to the shipbuilding industry that Glasgow was very famous for in the 1800s and early 1900s and 20th century. If a ship was described as being Clyde built, it was deemed to be the best quality that it was possible to get. So we very proudly print that on all of our circuit boards because we feel that we carry on that engineering tradition that Glasgow is so well known for.
I think it's fantastic, thank you. It's just, it's a wee Easter egg. So without even knowing it, you might never see these boards, but knowing that every single one proudly stamped Clyde built.
Every single circuit board. So at the start of the production line, this first machine is a screen printer. So we'll send a circuit board into the machine. That circuit board will match perfectly with a stainless steel stencil, 125 thousandths of an inch thick. That stencil will have some holes cut in it. I think I'll just grab one.
Cool, that'd be good.
All of the apertures that you can see on the stencil will match exactly an area on the circuit board where we want to place a component. Once the machine has a lock between the stencil and the circuit board, this machine will pass a set of squeegee blades over the stencil, and what it will leave behind is an area of grey paste. And I can show you that also.
What's the paste made of, Gordon?
It's microscopic balls of tin, silver and copper.
Cool.
So if we look at this circuit board, you can see the areas of grey paste on the circuit board itself. Now that paste has 2 jobs. The first thing it does is it acts as a sticky glue so that any component that we place on the board, it stays exactly where we place it. But then once the circuit board passes into the oven at the end of the line, we will heat the circuit board and the components, and that paste will melt and become the permanent soldered connection between the circuit board and the component itself. So we're completely lead free. We have been for many, many years. So let's see how we populate.
This is Gordon in his element.
I should point out that these circuit boards are actually from the brand new Magic DSM that we just launched a week or so ago. These are the HDMI boards that we're populating at the moment. So here we can see one of our 2 population machines on this line. This is an Ineo Plus made by a French company called Europlacer, and you can see the 2 heads populating 2 different circuit boards at the moment. So each head has a rotating barrel And each rotating barrel has 12 nozzles. So using a combination of positive and negative air pressure, we can pick up some of these tiny, tiny small components here and place them onto the circuit board into that grey paste that we saw earlier. So each one of these components, George, we can zoom in. Each one of these little black specks that you can see, if I put my hand here.
That's it, we got focus.
Each one of these little black specks is an individual capacitor or resistor. So they're pretty small.
So you've got tens of thousands of components on each reel, yeah?
Yeah, exactly. So Linn invested very heavily on new production equipment in this particular department 3 years or so ago. So the company spent over £1.7 million on new production equipment. This is part of that heavy investment. So our older machines that we had for 24 years, so we definitely got our money's worth. So hopefully these machines will be good for the next 20 or so years. So you can see a circuit board over here, Joe. So this is partially complete. You can see that there are some components on the circuit board. It will now pass into the second machine. Again, this is an Ineo Plus by Europlacer. This machine only has a single head with one rotating barrel, so 12 nozzles. So it places the larger components.
Yeah, they are quite a lot bigger.
You can see that they're much, much larger.
Yeah.
So there tends to be proportionately fewer of those on any given circuit board than the very, very small components. So both machines run approximately the same speed as each other, so no real backlog between machine 1 and machine 2.
How long does it take, let's say for example this relatively small board from Magic, how long does it take to make the complete pass from the top of the process here all the way through
so it very
where we
much
are now?
Depends on the complexity of the circuit board.
Yeah.
Some of our circuit boards take about 15 minutes per head for our very complicated circuit boards. Other ones like the Magic DSM HDMI board will be maybe 3 minutes per head all the way through the production line.
Amazing.
Once the machines are finished with the circuit board, it'll come out and stop here. So this allows the guys who work in this area to get a really good inspection of the circuit board. So they'll inspect by eye using a magnifying lens, and they'll look for any glaringly obvious errors. Once they're happy with that circuit board, they pass it into this machine behind you, Joe. This is one of our 2 ovens. So this is what's called a vapor phase oven, and it works in exactly the same way as a sauna. When you step into a sauna, the room itself isn't actually hot. It's the boiled water vapor in the air condensing onto your skin that gives up the heat that it took to boil it in the first place. This machine works in the same way. We need to heat the circuit board above 215 degrees centigrade, which is the temperature that the grey paste melts at. So in here we have a boiling fluid. It's a fluorocarbon fluid. It's called Galden HS240.
I doubt we'll be able to see anything,
Yeah,
but
it's a little bit cloudy.
just our reflections.
So the liquid that's in here boils at exactly 240 degrees centigrade. So we put our circuit boards in here, they sink down into the vapor layer. The vapor condenses onto the circuit board and gives up that 240 degree heat that it took to boil the fluid in the first place. That gently raises the temperature of the circuit board and all of the components above the melting point of the grey paste that we talked about earlier. And that's what becomes the permanent soldered connection between the component and the circuit board.
And another great benefit of this technology in an oven, it's just completely uniform. You know, it heats it uniformly, unlike a fan oven, unlike a conventional oven at home. You can measure the temperature at this point of the board and it'll be exactly the same as the other.
So before we had these machines, we had a very large 30-foot long hot air oven that gradually got warmer and warmer and warmer. The problem you have there is that the front of the circuit board and the back of the circuit board can be at 2 different temperatures, and this can cause problems. This oven avoids that problem and heats the entire circuit board at a uniform and gentle rate. So it's a much higher quality process, a little bit slower than hot air, but much higher quality. So once all of the circuit boards have been through the oven, all of the components are now permanently attached to the circuit board. So one half of this team is now finished with the circuit board. All of the surface mount components are now fitted. So the next thing we need to do is inspect the job that we've done. And we do that over here. So this machine is our inspection machine. So the white and blue box that you can see will tell the machine what circuit board that we're putting into it, and then it will take an image of every single component on that circuit board, and it will compare it to a known good image it has of a perfect board, and it will compare every component. Anything that it finds unsure or thinks there may be a problem, it will flag it up so that the operators who work in this area can inspect it by eye using a microscope or an eyepiece. So we want to come this way. So this is our repair station that you can see here. So we have the microscope that the guys will use to really very closely inspect all of our circuit boards for that really high quality, super detailed inspection and examination. I'm going to join you, Joe. So now we mentioned that there are two types of technology on our circuit boards. There are surface mount parts, they've all been fitted to the board, but we still need to fit the through hole, the larger parts. Now that's all done by hand. So the benches in the middle of the room that you can see here are our crack team of operators. So they'll take all of the components necessary to complete that board, and they will fit them by hand to the board itself. Now we don't have the benefit of the grey solder paste that we saw earlier to solder the part to the circuit board. But what we do have is these two machines here. These are called selective solder machines. Essentially they are CNC controlled little fountains of molten solder, and they will pass around the underside of the circuit board and solder the component to the circuit board itself. Once the boards come out of the machine, the guys will give them another inspection, another visual inspection. They'll repair any defects that they find, if they find any.
Is it quite rare?
It's pretty rare. We run a very high quality process here. Our first time pass rate sits between 93 and 95%, which is very high, but we're not a high volume manufacturer. We're a low volume, high mix, high quality manufacturer. So we're not like a Motorola or a Nokia who churn out tens of thousands of circuit boards every day. We focus on quality more than quantity.
It's something which is evident throughout the entire process in metalwork and everything. There's no one saying you need to have made 10 of these by now. It's saying no, you need to make them right.
So once we're finished with the boards, we'll pass them over to Gail here, who'll do all of our electrical testing.
Give a wave, Gail.
So Gail tests all of our circuit boards. So this is the first real electronic test of any of our circuit boards. It's not a functional test, it's an electrical test. So we'll send a voltage through the board, and the test system will flag up any potential problems. So you can see the gold pins that will make contact with the test pads on the bottom side of the circuit board. Gail's putting a Magic DSM display board in. The test is now running. Anything that it thinks is a problem will flag up to Gail, and she will then inspect it to make sure it is a genuine fail or a false fail. But once she's happy with it, she puts a pass label on the circuit board. And if you ever see any of our circuit boards, there will always be a pass label on it, and they will almost always have Gail's name on it.
All of them will say Gail. What's the what would constitute a false fail at this stage? What would cause that?
It could be one of the test pins isn't connecting with the bottom of the circuit board correctly and gives a spurious reading. But this machine will look for wrong value components, damaged components, missing components, all sorts of various electrical issues that we can fix on the circuit board.
Perfect. Thanks for your time, Gail.
So once we're done here, the circuit boards are complete. Now we're going to go next door and see where they meet the metalwork that we saw downstairs. So if you want to follow me. So this is our main manufacturing floor. This is where the circuit boards and the metalwork come together into the finished product. So if you want to follow me this way, this is our most famous build station. This is where every LP12 starts its life. You can see we have two LP12 setup jigs and a brand new plinth ready to be assembled. So this is probably a good point to explain Lynn's production method that we call single stage build. In the final assembly area, you won't see a production line. You won't see one person doing the same job for 8 hours a day. We run a system called single stage build, where one person will collect together all the components needed to build a product. They build the entire product, they test the product, and they put their name on the back of the product. The reason that we have single stage build is in the 1970s, when Lynn first started as a company, we really couldn't make the Sondek LP12 fast enough. It had taken hold in the marketplace and people were buying it as soon as it landed in shops. So Ivor called a meeting of all his department heads to discuss how do we make the LP12 better and quicker. He asked his assistant, can you make sure we have an LP12 at the meeting? She appeared with one that he didn't recognise, and he asked her, where did you get this LP12? And she said, well, I couldn't find one, so I just built it myself. So that's when Ivor realised that the way to build the LP12 is single stage build, with one person building the entire product. And we've stuck with that philosophy ever since. So any Lynn product you ever see will have someone's name on the back of it. And the likelihood is that person probably still works here today. So over on this side, you can see some of these sub-assemblies for the LP12. You can see some Magic, these Magic chassis, well, sub-chassis with the brand new carousel bearing, ready to be assembled. Ooh, lovely.
Shiny.
We have some arm boards here. And
oh, here's some bearings.
yeah, here we have some lovely carousel bearings that we introduced at the start of this year in March. A revolutionary bearing at the heart of the LP12 that currently is flying out the doors.
Yeah, we couldn't be more pleased with that, could we?
So if you come this way,
So what's the story with all of the crates?
all of the, what, sorry?
The crates? The sort of the cages almost.
So all of our build stations are pallet sized. This means that our automated delivery vehicles that we have that run on the blue areas of the floor, if we're not using a build cage for a particular product, we can lift it up and put it into our warehouse and bring out a build cage for a product that we are building. So it really maximises the space that we have here in
kind of
final assembly.
Yeah, it makes our final assembly modular.
Yeah, effectively. So over here, you can see a Climax amplifier begin its life. You can see the fully CNC'd metalwork, the billet aluminium chassis. We'll see a little bit more about that as we go around the factory. But once this is built, Sharon will test it. She'll put her name on it, and that will live on the bottom of the on the bottom of the amplifier forevermore. So if you want to follow me.
Yes. So I'm seeing if we can find any of our automated goods vehicles. Or are they all on holiday?
So this area here is our module build station. This is where we build the integrated amplifiers that live on the back of our Climax 350, our Acubaric and our Acudoric loudspeakers. So this is one that's come back for upgrade. So you can see the complexity involved in building one of the Climax 350 amplifiers.
So will this be a catalyst upgrade?
Potentially, I guess it probably will be. It's already got dynamic.
Yeah.
So I guess this is probably a catalyst upgrade.
Excellent.
So over on this side is our service department. So if you've ever had cause to get in touch with Lynn, perhaps you wanted some advice on a setup for your system, or perhaps you have an issue you want to deal with, it's one of the guys in this area here that you'll have spoken to and who will deal with any products that come back to the Lynn factory.
A hive of activity.
So this next area here is one of the newer, more exciting parts of the Lynn factory. This is our brand new machining centre. It's only been here for a few years. It's something we're very proud of and very exciting. There's loads of new possibilities that we can investigate in the machining world. Here we can see some of our billet aluminium. Turn that round. So this is eventually going to become a Climax piece of Climax metalwork. It could be a Climax DSM, it could be a Climax solo amplifier. This is a very specific grade of aluminium that we use. It's called C250 Elox Plus, and it's made by a German company from Hamburg called Gleit. The reason that we use this is that they have a very unique casting method. So it's called continual casting. So it's a continual tongue of aluminium that keeps coming out of the blast furnace. What that does is gives a very uniform grain structure to the aluminium, because when we machine this and anodize it, especially in silver Climax metalwork, you can see the grain of the aluminium beneath it. So a very specific grade of aluminium, a medium hard grade of aluminium, which machines really well. And I think I can show you that.
Oh. Don't look at it, don't breathe on it.
Now, I wish that we could manufacture and sell Climax metalwork like this, but because this is a raw aluminium finish, it can oxidize. But this is a piece of Climax DSM metalwork that's just been machined from a 5-axis CNC machine behind me. So this machine here is a 5-axis CNC machine.
Ready for your close-up?
So this means that the cutting head and the bed that the cutting piece sits on can move in many different axes. And you can see that it's cutting away just now. So on this side of the room, there are two 3-axis machines, so they can't move in as many different directions, but for the material that they cut, they don't need to. Now, we can see some of the cutting tools that we have here.
It's a bit grisly.
Yeah, it's like a torturer's armory.
Yeah.
But some of the investment that Lynn has made in this tooling is very significant. Some of these tools cost thousands of pounds each. In fact, this one here, that we call the fly cutter, this cost £30,000 to have made for us. So it's a very big investment by Lynn in machining and the capabilities that we can do here in-house.
What happens to all this discarded spore?
So all of this material will of course be recycled. We capture all of our waste material and we recycle as much as we can. We are very conscious of our footprint here in the factory. In fact, the roof of the building is entirely covered in solar panels. So yes, we do try and be as environmentally conscious as we can be. So you want to come this way, Joe?
Yep. Wow, sorry. I just need to take a look at the machining inside this Climax metalwork. It's like Damascus steel.
So you can see each one of the step overs where the cutting tool has moved to eventually mill out the entire piece. Now, we don't just do this for cosmetic reasons, as admittedly as beautiful as it is. There are very significant engineering reasons why we use a solid block of aluminium for metalwork. Here is where our power supply will sit, and here is where the delicate signal generation side of a Climax DSM will sit. This thick aluminium wall that sits between the two gives really good isolation between the relatively noisy power generation side and the very delicate signal generation side.
That's about 5 or 6 mil thick, isn't it?
It is indeed, yes.
Yeah. Wow. Cool.
So, you want to follow me?
Yes.
So behind me, we can see the great-grandfather of the machines you've just seen. This is our Akuma lathe. So this machine is where we machine all of our LP12 inner and outer platters. You can see some here. So these are some of the castings that have come in for machining, and this is the almost finished piece. So these are made from Mazak or Zamak, which is a zinc alloy. Very heavy, very dense material. We machine them all in-house. So this is where your LP12 inner and outer platters are bought.
That's a very old looking piece of machinery.
It is, but it is still a direct descendant of the newer CNC machines. It's still a CNC controlled lathe,
Yeah.
but just a little bit slightly older. Older doesn't mean obsolete.
No, absolutely not. So here's one of our automated goods vehicles.
This is indeed one of our robotic delivery vehicles. These have been here since the mid-1980s when the factory was first built. People seem to think they're very high-tech, and they absolutely were when the factory was first opened, because the factory was designed as an entirely functioning machine unit. So our warehouse is completely automated, no one works there. It's serviced by our delivery vehicles and robotic cranes. So again, when the factory was first designed, it was an absolute model of efficiency, and we've tried to maintain that to this day.
And we make the software that runs them all, you know, if they...
Yes.
Yeah, so really everything, we try and be as self-sufficient as possible, bring everything in-house.
Yeah, we're a very self-sufficient company. We try and control our own destiny as much as possible. So the surface mount department, for example, that you saw next door, it does cost Lynn a lot of money to have that process here in the factory. But we get real benefits in terms of quality and timescales because we're in control of all of that. If we outsource that particular process to the Far East or perhaps Eastern Europe, you do lose control of some of those key factors. So yes, we try and control our own processes as much as possible in-house.
Good stuff. Where are we going next?
So we're going to go this way.
Awesome.
This is a small woodworking shop.
What goes on in there?
This is where we create some prototypes for speakers, for that kind of thing. A little woodworking and metalworking shop that we can use for rapid prototyping. Now, behind me in here is our research and development area. I'm sorry, but no pictures. I'd love to take you guys in there, but unfortunately we can't go in there today. Lots of very special magic things happening. That's magic with a K, obviously.
Enough said.
So you want to follow me this way? So this is our main goods in, goods out floor. Behind me is the main office for the company. Now you'll see it's pretty quiet just now because thanks to COVID-19, anyone who can work from home is currently working from home. We are taking COVID-19 very seriously, obviously. This door here is where everything that comes into Lynn comes through this door. It's scanned, given a barcode so that we have an accurate stock of everything that we have, and that can be individual components for products, food for the canteen, detergent for the cleaners. Everything comes in through this door. All finished goods go out through these two doors here. So late on every afternoon, delivery vehicles will appear here and we will load individual retailer orders. You can see individual orders here. These will be a pile of Lynn products for an individual retailer somewhere in the world. They will go into the back of the delivery vehicle, and Glasgow Airport is 25 minutes that way. So a pretty quick turnaround. Over here we can see our warehouse area. So over here, shrouded in darkness, is our automated warehouse. So I wish there was more to see here, but because it's robotic, we don't need lights on, no one works in there. What I can tell you is that there are around about 2,200 pallets in our warehouse area.
We'll see if we can get a shot of the big blue box from outside so that you can maybe through a window or something.
Absolutely.
Oh, just if you wanted an overview of the final assembly floor. And you can see those signature coloured pipes, Richard Rogers style.
So here you can get an idea of the size of Lynn as a company. We're not a massive company. We're around about 180 people, but we're all self-contained here in this one building with the exception of one or two salespeople who work in different markets. But yes, everyone from our service team to our machining centre to final assembly, we're all based in one very efficient factory. And you can see one of our delivery vehicles travelling along the floor. This is number 2. This is Louis. They're called Huey, Louis and Dewey.
1, 2, 3.
1, 2, 3.
There was a fourth though.
There was a fourth one, but he very bravely gave up his electrical components so that his three brothers could live.
Yeah.
So if you want to follow me this way.
Of course. And here's the SMT. Come full circle.
And on through. So this particular area we call the ballroom. Normally it's pretty empty, but because of the COVID-19 crisis, we've turned this into a second staff eating area with all of the tables adequately socially distanced so that people can maintain that distance. Normally we have a whole variety of different things happen in this area. Once a month we have a staff chat where Galada, Managing Director, will gather everyone in the company here and we'll talk about where we've been the month previously and where we're going the month ahead. So we're always kept informed of how the company itself is doing. Out the window behind me, you can see the blue box, or our warehouse that we just had the very briefest of looks at.
Don't know if you can get an idea of scale there, but someone said multiple blue whales could fit in there. It's very big, but no one needs to go in.
No one needs to go in. Apparently it can hold 131 million golf balls. I don't know who calculated that.
I like it.
So that's the Linn factory, a very quick tour around the Linn factory. Hopefully you enjoyed that. The last thing we'll do is we'll go and take a little visit to our Linn home, our demonstration space. So you'll join me downstairs. So that was a little bit of a tour around our manufacturing side of the factory. Let's now take a little look in the Linn home, our dedicated demonstration space. Welcome to the Linn home. This area in the factory is dedicated to demonstrating our products in the best environment possible. So here we can demonstrate individual systems and products, and equally we can demonstrate our multi-room capability. Behind you, if Joe swings round, you can see Custom DSM, our new dedicated CI streaming product. It's powering the bedroom area and also this kitchen area with multiple ceiling and in-wall speakers.
Yeah, so it's a dedicated multi-zone network music player.
Yeah, absolutely. And like any other of Linn's DSMs, it can talk to any other Linn DSM. So this entire room can multi-room any audio to the whole system, to every system in the room. So if you want to follow me over here, here we have a Select DSM with its beautiful glass dial on the top surface of the product. Right next to it, we have the iconic Sondek LP12 turntable in gloss white, one of the brand new coloured plinth options that are available on all LP12s at this moment in time.
And this is our Magic LP12, this is our entry-level.
Magic, entry-level LP12. And they're playing through a pair of Linn's Series 5 530 loudspeakers with its beautiful thistle fabric here. Well, you are in Scotland after all. So if you'd like to follow me over to the other side of the room. So here we have the flagship, a full Climax system using a Climax DSM and a pair of integrated Climax 350 loudspeakers. The very best that we can do.
So these, when we were in final assembly, the extruded aluminium chassis that was being upgraded.
Exactly. So you saw one of these being manufactured
one of these
in the machining centre.
Yep. And then that was ready for an upgrade. We presumed it was a catalyst, but that contains all of the digital to analog conversion and the amplification for these speakers.
So in a pair of 350s, there are 12 DACs. There is a DAC for each drive unit. These two units here are the lower bass. This is the upper bass, and then we have here a 3K array with mid-range, tweeter and super tweeter. So each Climax 350 has 3000 watts of peak power. That's 2000 watts of power to the lower bass, 600 watts of power to the upper bass, then 400 watts of power spread between the mid-range tweeter and super tweeter. So yes, it's our flagship system. It sounds
These are the big guns. I wish we could let you hear it.
But over here, we have the brand new Magic DSM. So Magic DSM was launched just over a week ago. You can see we partnered it with a beautiful teal Magic LP12 as well. And we're playing through Magic 109 loudspeakers in a custom white finish.
Gorgeous. The new Magic DSM, it shares a lot in, visually to Select DSM.
It does. It shares that same family look. It has all of the same control functionality with these 6 programmable smart buttons that you can see here, and also the configuration button where you can access your sources, you can change a volume, you can stop, start, play, you can even go into a settings menu and configure software updates.
And Wi-Fi and Bluetooth.
Wi-Fi and Bluetooth,
yeah.
all of that stuff.
It's fantastic, part of a new crop of network music players that we're putting out.
Absolutely, yeah, and it's a fantastic sounding product, a real jump in performance over the old Magic DSM.
Yeah, and we've been really chuffed with its reception so far. So these are available for booking for demonstration at your local Linn specialist retailer as well now.
If you'd like to hear the new Magic DSM, please get in touch with your nearest Linn specialist.
And if you don't know who that is, go on our website and there's a find a store near you function there.
Okay, well, thank you very much for taking the time to join us today. Hopefully you enjoyed that. If you have any questions about anything that you've seen today, please leave a comment below and we'll try our very best to answer any of those questions. So, thank you very much.
Thanks very much.